After the first example, where there was no restriction whatsoever on minting or burning a token, let's look at a somewhat more realistic example. And I copied the free module to a new module called signed and want to modify it now. And the idea for a more realistic example is that minting and burning can only happen if the transaction that tries to do that is signed by a specific signature, by the owner of a specific pub key hash. So in order to do that, we need a parameterized minting policy where the parameter is the pub key hash we are checking for. So let's add that here. And then we have an additional argument. Let's call it pkh. And now we can't ignore the script context any longer. And we can just use the tx signed by that we have seen before, which takes the tx info, and that we can get by script context tx info of the context and the public key hash we are looking for. Now, of course, these other definitions have to change accordingly to take the parameter into account. So policy is no longer a constant. It becomes a function that depends on the parameter. This is now similar to what we did before. So we have to apply this to the lifted parameter. So this now, because make policy is now also a function, so I must compose it with wrap minting policy. And now again I can use Plutus tx dot apply code as before, and Plutus tx lift code pkh. So finally, for the currency symbol, this now also becomes a function that takes the pub key hash as argument. And I can simply compose here. So this is very similar to before. Now for the off-chain code. We don't have to change very much. For example, the parameters we can leave as they are. We don't have to add the pub key hash here to the parameters, because one of the features of the contract monad is that you can look up your own pub key. And minting, calling this mint function, only makes sense if you actually want to mint the currency that's given by your own pub key, because otherwise the minting policy would forbid it anyway. We should rename this though to signed schema. Okay, and now here. So we do have to look up our own pub key. We can do that with contract own pub key. And then we can add a line here where we compute the pub key hash from that. Pub key hash pub key. However, that can be shortened. It doesn't have to. I mean, this is perfectly fine, but I would probably combine these two lines to one, using the fact that contract is a monad and hence in particular a functor. So recall, functor has this fmap function. So if f is a functor and you have a function from a to b and an fa, then you can turn that into an fb. Also remember, the prototypical example of functor is lists, in which case fmap is just the usual map on lists. So if I have map +1 of the list 1, let's say ints 2, 3, then I get the map 2, 3, 4. So that's the usual map. But for lists, map is the same as fmap. So I can just as well do fmap. And there's also an operator version of fmap. So you can write this identical like so, using this dollar in angular brackets, which is often nicer and reads nicer. In particular, the dollar looks similar to the usual dollar, which is just function application. So that somehow shows that this fmap is a bit like function application, just lifted into a functor. So I want to apply that to f being contract. and this FA being own pub key. So we have something of type contract pub key, and we have the function pub key hash, which goes from pub key to pub key hash. So using fmap, we get something from contract pub key to contract pub key hash. So I can immediately get the pub key hash here if I fmap pub key hash over this own pub key. And then after all, I don't need this line anymore. Okay, now that I have the pub key hash, I can apply it to the currency symbol function to get the actual currency symbol. That depends on this parameter. And I can do the same for policy here, which now also is a function that takes the pub key hash. The rest should be fine. Here I just have to rename to signed schema. Here as well. And I believe the trace is still perfectly fine. One thing I forgot is here I also have to rename to signed schema. Let's try the trace. So everything seems to work. We get the 3 forges, where the last one is actually a burning because it's a negative amount. And we get the same amounts again, so 333 in the end in wallet 1, 444 in wallet 2. However, note that now these are different tokens. They have the same token name, ABC, in both cases, but the currency symbol is different. And that is because now we had a parameterized minting policy, and each wallet applies its own pub key hash to it. So the parameter is different, so the resulting script will be different, so the hash of the resulting script will be different, which is the currency symbol. So we get different tokens. Wallet 1 can only mint this token, and wallet 2 can only mint this token. Because wallet 1 can only sign for this one, and wallet 2 can only sign for that one. The wallet only has its own signature to use to sign transactions. So this is a more realistic example, which might actually be useful in practice. It's a bit like a central bank where the pub key hash identifies the central bank. So similar to fiat currencies like US dollar or euro or yen, where supply is determined by a central bank. The central bank can decide to mint more money or take money out of circulation to control the total supply. And this is somewhat similar, this parameterized minting policy that we have seen here. So wallet 1 is in control of this currency and can mint and burn it freely, but nobody else can. And wallet 2 is in control of this currency and can mint and burn it freely, but nobody else can. So it's a bit analogous to, this being something like US dollar, and wallet 1 is the US central bank, and so this is like the euro, this currency, and wallet 2 is the central bank for the euro.